Okay, we have to another integral on the board. We've got the integral of x over 1 plus cosine x dx. Okay, to get started with this, just noticing this denominator was making me think what we could do on this is use a Weierstrass substitution or a half angle substitution. I did it that way first and it wasn't too bad, but I actually found it was a little better if I did it using a trig identity. So what we can actually do on this is use the half angle formula for cosine. It just tells us that for cosine x over 2, this is going to be equal to plus or minus square root of 1/2 1 plus cosine x. And so I think you can kind of see my motivation for doing that, because what we have here in the denominator is exactly what we have in here. We just kind of need to isolate this. So first what I'll do is, if I just square this and get a value for cosine squared x over 2, the nice thing about doing this is the plus or minus goes away when we square it on the other side. And then here, we don't need absolute value because you'll notice cosine is never greater than 1, so this is always going to be positive. So we end up over here with half times 1 plus cosine x. But then I can just multiply by 2 on both sides. That way I get rid of this 1/2. And what that does is give me a way to rewrite this whole denominator. We'll write it as 2 cosine squared x over 2. So rewriting this, we'll have our x here. I'm going to take the 2 up front. We'll have this as 1/2 here. And then this is going to become cosine squared x over 2. But actually, the way I prefer this is to bring this into the numerator and write it as secant squared. So let's just do a quick rewrite. We'll write this as x secant squared x over 2 dx. But doing it this way, you'll notice that this secant squared x over 2, this is an easy integral. And we could differentiate this. This is perfectly set up for integration by parts. So we'll come over here to the right and we'll use the DI method or tabular integration. And what I'll do, we'll differentiate x. And we'll integrate secant squared x over 2. Derivative of x, that's going to be just 1. Derivative again of 1, that's just 0. Derivative of secant squared x over 2, this is going to be just tan x over 2. But don't forget this 2 here, because we need to bring this up front when we integrate. And so now we'll just integrate again. So the integral of tan x over 2, this is going to be just natural log absolute value secant x over 2. But we need to bring the 2 out front again, and we have this 2, so this is going to become a 4 over here. And so now we can just kind of get our solution on the diagonal. So for this first part we're going to up here, this is going to be 2x tan x over 2. And then for this part over here, we're going to have minus 4 natural log secant x over 2. But don't forget that we have this 1/2 in front, so I'll just put this in the denominator and write it all over 2. And then we'll do some quick simplification if I can get a little more space. So what's going to happen here is I can cancel 2 with 2 here, but then I have to divide by 2 here. So this is going to become a 2. So for my final solution, we're just going to have x tan x over 2 minus 2 natural log absolute value secant x over 2. Add a plus c, and that's it. Okay, there you have it. Interesting problem that I just made up this morning. Thanks everyone for watching. Have a good day.